Hello everybody, and welcome to another segment in Introspect Technology's High-Speed SerDes Links video series. My name is Miles Williams, and I'm the Technical Marketing Manager for Introspect Technology. Today's topic will be how to perform a bit error rate test with resulting bathtub curves using Introspect's SV2C Personalized SerDes Tester. The SV2C is an 8-lane, 32 gigabit per second USB modular instrument for SerDes validation. This tool is part of our C-Series product line, a complete suite of ultra-compact, highly flexible test instruments which are ideal for applications requiring deep characterization capability. Now let's begin the demo. In this demo, we will be using Introspect's ESP software, which is highly scriptable and highly flexible Python code language. And by default, the system comes up as 28 gigabit per second, but I'm going to change the data rate to a rate that is more in line with communication standards. So I'm going to use 28780 megabits per second. Then I'm going to set up the transmit channels, which we're going to send data out on to be analyzed. So here I'm setting up the transmit channel list, and we're going to perform measurements on all 8 channels. So I'm going to send data out on all 8 channels. We're going to use a pattern that's a little more stringent. So I'm going to use a PRBS 7. And everything else will be set at default. Then I'm going to set up what we call a BERT scan, which is doing a BERT measurement with the resulting bathtub curves. Let me add that component. Now let me set up the receiving channel list. So these are the channels the data is going to be received on. We're going to receive on all 8 channels at the same time. And the expected received pattern will be PRBS 7. And everything I'll just leave it default. The other item we're going to change is the bit duration, which is the number of measured bits performed at each phase at each position. So currently it's 1e to the 6, so I'm going to change it to 1e to the 9, which is more standard with communication standards. So now we're set up and ready to run. So let me run. So the system is now going through and looking at each channel, performing a pattern sync at each channel individually. Then it's going to calculate the bit, or it's going to measure the bit error rate, and then send back the data. And you can see in the log file, it was extremely fast. It took less than 20 seconds to perform bit error rates on all 8 channels at the same time. Now let's go to the results. So you can see here, we've got this chart which shows the bit error rate along the left and the phase in picoseconds along the bottom, and the number of channels being displayed along the right. Now if I just lower this down, you can see the analysis for each channel. We've got the channels, we've got the random jitter in picoseconds for each channel, the deterministic jitter for each channel, the total jitter for each channel, and the estimated bit error rate along with the eye center for each channel, all in picoseconds. Additionally, you can look at each channel individually. So I'm going to go to the first plot. This is channel 1, and you can scroll through and look at each one. That's channel 2, channel 3, and so on, all the way up to channel 8. And all of these results are saved at each run on your system every time. So you can go back and look at the data and analyze each one. And that's how you do a simple bit error rate test with resulting bathtub curves. I want to thank you for joining us today. If you have any questions, please feel free to email us at any time at info@introspect.ca or visit us at our website at www.introspect.ca. Have a great day, everybody.